Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 327, I chat with Rich Chernock, head of the technical committees that are working on finalizing the ATSC 3.0 terrestrial broadcast system. Coming up next.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded October 27th, 2016. Episode 327. What's up with ATSC 3.0? This episode of Home Theater Geeks is brought to you by Epson's new EcoTank printers. With Epson's line of SuperTank all-in-one printers, you can print thousands of documents without running out of ink. EcoTank is loaded and ready to print when you are. Visit epson.com/ecotank to find out more. And by Grasshopper. Stay connected and run your business from your mobile phone with Grasshopper. To save $50 on your order, visit trygrasshopper.com/twit. Hi there, Scott Wilkinson here, the home theater geek and editor of avsforum.com. This week's guest geek is Rich Chernock, the Chief Science Officer at Triveni Digital, a company that makes products for broadcasters, but he's also the head of the Technology Group 3 of the Advanced Television Systems Committee, or ATSC, which is working on the ATSC 3.0 broadcast standard. And that's what we're going to talk about today. Hey, Rich, welcome to the show.
Hello. How are you doing?
I'm doing great. How about yourself?
Good. Pretty good.
Yeah. I met you at NAB last April, and we had a chance to chat, and you were part of the podcast from that show. But here we get a chance to talk in more depth about ATSC 3.0, which is coming right along. Before we get into it, though, I want to make sure that everybody knows, those who are watching live at live.twit.tv can join the chat room there, or you can go to irc.twit.tv. And once you get in there, you can post questions, and I will pass along as many as I can. It helps if you put my screen name, which is my name, Scott Wilkinson, no dots or dashes or spaces, into your message, anywhere in your message, and then it appears in a different color on my screen. My eye gets drawn more immediately to it. So, Rich, let's start with an overview of ATSC 3.0 and maybe a little bit of what led up to this point in time.
Okay. So ATSC actually creates the standards for terrestrial broadcast television used in the United States and a number of other places. The TV that we're watching today, what's over the air, has become known as ATSC 1.0. You may remember a little while back that there was a transition from analog broadcasting in standard definition to digital television in high definition.
That was maybe, close to 10 years ago?
The final transition, I believe, was 2009. That's when everything switched over.
Oh, okay. So
it took place over time. Yeah.
Yeah. Okay.
So digital TV, is a big change. To the viewer, TV still operated pretty much the way it did before, but all of a sudden we had high definition video. We had surround sound. We had a number of new things coming along. ATSC 1.0 was quite successful. It met really the requirements of the time, but the world's moved on. When we started the digital television work, television was sort of a unique entertainment device. If you wanted entertainment in the evening, you'd sit down in front of your TV and watch. These days, if you want entertainment, you pick up whatever device you have and go for whatever content you want, wherever you are, and you get it. The world changed quite a bit from that point. Mm-hmm. So a number of people looked at what was going on, looked at the broadcast industry, looked at the business, looked at the competition, and decided it really was time to go for a next generation television broadcast system. Thus the work on ATSC 3.0, which is a brand new system, state-of-the-art technology, offering a lot of advantages over what we have today.
Mm-hmm. Now, I have to ask you, we now have ATSC 1.0. We're working on ATSC 3.0. What happened to 2.0?
2.0 got a little bit squeezed. Well, I can't remember exactly when we did this, but people were looking at technologies, looked at what had happened, looked at what people want, and started working on a set of backwards compatible enhancements for broadcast television, adding new coding technologies, adding IP, adding interactivity, but doing it in a way that it was totally backwards compatible with what was on the air then. When that work stabilized and was getting pretty much ready, the work on ATSC 3.0 had begun and really accelerated, offered so many new capabilities that when ATSC 2.0 was finished, it didn't make a lot of sense to deploy it because 3.0 was going to be coming fairly soon and offered so much more. So 2.0 standards existed. Some people were experimenting with them. There's a number of new capabilities. Some of it is actually pulled into 3.0. But it was essentially a case of something new came along that was a lot better, and it sort of took over.
Was 2.0 also high def, 1080p, or 1920 by 1080? Was that one of the differences?
It was HD, but it used the next generation of video coding technology, so it did the HD in half the bandwidth. Same with audio. It went to new audio coding technologies. So similar quality, but again, half the bandwidth.
Mm-hmm. But again, now we've got, you go to the store, you can almost not find a 1080p TV anymore. They're all 4K. So that's one reason, I'm sure, why, hey, it's time to move on to that, right?
That's a piece of it, but it's not all of it. 4K may not be the most interesting thing that's happened to video.
I agree with that, by the way.
Good. If you take the typical viewing situation, the distance that people place their couches from their TV, the typical size of TV in the house, and typical eyeballs, you almost can't tell the difference between 4K and HD. Your eyes just aren't good enough. Now, if you stand next to the TV or you put a 120-inch TV in the room, well, maybe that'll work. Other things that come along in the UHD umbrella are high dynamic range, wide color, high frame rate. These are things that are immediately obvious to almost anyone on any size TV in typical viewing conditions. So it may well be that the most interesting advances in video quality are not more dots, but better dots.
Now, I did hear an argument just this morning at the SMPTE Tech Conference about why 4K might be visibly better, even if you can't see the difference in detail, which what you just mentioned is certainly true. But at a higher bit depth, or a higher pixel density, you can also do things like more low-pass filtering to avoid visible artifacts like jaggies and stuff like that. So that which would be potentially visible from the typical distance on a typical size TV. I just thought that was kind of interesting.
And that could well be. It makes sense, but there's other factors as well, because if you look at the difference in bit rate needed for these different types of enhancements to video, if you go from HD to 4K, you need about 3 times as much bandwidth for the same similar quality. If you add HDR, you may need to add maybe 20-30% more bits. Wide color is even less. High frame rate is somewhere in that ballpark. So 4K is actually quite expensive. Now,
in terms of bandwidth needed.
Correct. But in terms of production, content creation, the extra resolution really makes a difference. What a scheme I've heard a number of broadcasters talk about as a possibility is to do content creation in 4K and HDR, wide color, all the rest of that, downres it to HD 1080p for broadcast, and let the TVs upscale it back to 4K, but keep the HDR and all the rest. You get a lot of the advantages that you were talking about without having to spend a lot of bits getting it across the air.
Okay. But then you're talking about two resolution changes, one from 4K down to HD, and then in the TV from HD back up to 4K. It seems to me that that might cause some problems of its own, depending on how good the scalers are.
These days, the scalers are pretty good. I don't think you're going to have much issue there. But these are all things, and a lot of these standards, a key part is that they provide a toolkit for the broadcasters to do what they think is appropriate for the business needs. So they have options, and if a broadcaster wants to put on 4K and HDR there, they can do it. If they want to send out 1080p, they can do that as well.
Well, we have you sent me some graphics, and I greatly appreciate that. Let's take a look at the first one, which kind of has some indication of the different types of capabilities or features of ATSC 3.0. And tell us about some of these.
Yeah, so when I put this together, it was sort of trying to catch some of the high-level bullets, major functions and features that ATSC 3 gives, and it doesn't cover all of them. There's a lot more. But a big focus on video and audio quality, so Ultra HD, 4K, HDR, high frame rate, white color. I've been talking about that a little bit.
Yep.
Audio, next generation audio systems move quite a bit forward, and I think we'll get to that in a little bit more detail later.
We will.
Media transport, moving away from the MPEG-2 transport that was the core of the plumbing of earlier systems into using IP transport. Basically, you can think of broadcast television as now being an extension of the internet, also allowing hybrid between services composed of broadband and broadcast components.
Now, wait a second. When you talk about being kind of an extension of the internet, this is still being broadcast wirelessly over the air, right?
Parts of it, yes.
Oh, but parts of it not.
The hybrid thing allows a broadcaster to put together a service that's composed of broadcast elements and broadband elements. And one simple example of this might be, say in LA, where there's lots of different nationalities, lots of languages spoken. You might send out a program, a television service that has video, and it has audio in the broadcast in maybe 2 languages that are very popular, Spanish and English, for example. But you've got a fairly high, a significant Asian population. You can choose, the broadcaster can choose to make other languages available over the broadband side that are synchronized. And people who prefer to hear it in, say, Japanese, can pick that on their TV, and the TV will pick the audio off broadband and the video off broadcast and combine them.
Wow, and they can really be that tightly synced.
Yes, they can be totally synced.
Wow. Okay. The one of the other things that was in that diagram or that spreadsheet that you showed us here, advanced PHY with an alphabet soup after it.
Yeah, that's the magic part.
PHY, I think, is physical layer, right?
It's physical layer. That's correct.
And we're going to talk about that in a little more detail in a bit.
Yeah, I have to admit that to me it's still magic. I'm learning it. I'm really a bits and bytes type person. But there's lots of people who were willing to spend time and teach me all about it. This is the modulation. This is what goes between the RF signal that goes between the antenna or the broadcast antenna and your receive antenna. And technology's moved on. A lot of new advances have been made. Lots of things have changed. And the bottom line, I'll get into it a little bit later, but ATSC 3 modulation, or the RF transmission, is much more flexible, much more robust, and has much higher capabilities than we've had before.
Okay. Then if we take a look at graphic number 2, we have sort of the components of the new ATSC 3 and how they're sort of combined together. Tell us a little bit about this diagram.
Yeah, the reason for putting this together is, earlier systems, even if you go back to analog television, that was really simple. You started off with one video and one audio. A bit later, somebody got a bright idea and figured out how to get a second audio stream in there. And most of that was pretty much kept with digital television, ATSC 1. One video, one or two audios, maybe captions buried in the video, and that's really all you had. ATSC 3, the service model is expanded. You can have video, you can have multiple videos, different camera views, insets, picture-in-picture type things. You're not limited to one. Audio, much richer, as I mentioned. It's not one or two, it's however many is appropriate. Captions, much more capability. Captions are now treated as a component rather than a piece of the video. And you can have interactivity. The broadcaster can have different events, different programs, if you will, made up differently. So there could be, like the one you see on the very left has a lot of components, a video, audio, multiple closed captions, and interactivity. And it could go to one that's, the next program is something that's more conventional. One audio, one video, one caption. And you can kind of mix back and forth. So this really means that the broadcasters aren't limited to what television used to be. They are now able to do whatever they can dream of. So this means new innovations, new business models, new services.
So as you say, much more flexible, a lot more things you could add if you wanted to.
That's right. And I think over time, we're going to start off with simple things that look like today's television, because that's what people know how to create and produce, and that's what viewers are expecting. But over time, broadcasters are going to experiment and add more and more capabilities and make more use of what's available to them.
And then finally, we have a system diagram, graphic number 3, and I wanted to take a look at this. Okay, this is the one that we saw at NAB. So this is the whole kit and caboodle. This is how, all the way from the TV station to your TV.
Correct. So it's, broadcast television is a fairly complex system. Now, of course, what this doesn't quite show is all of the content creation that comes before the TV station, but that's a different story.
Right.
And what's on here is, in each of the boxes, the TV station, transmitter site, and the home, is a view of, the components that are needed for ATSC 3, but also by color coding, which things need to get changed to go from ATSC 1 to ATSC 3. So there's a number of things that will need to be either upgraded or in some cases new components. Overall, the functionality is pretty similar. We still have a TV station that has to take in content. It has to encode it. It has to multiplex it, add metadata, things like guide information and matching up audio and video to make programs. Then that goes out to a link to a third of the way through, a link from the station to the transmitter called the STL. Then the transmitter, where there's an exciter that does all the magic to turn it from a stream of bits into something that gets modulated, the transmitter, a mask filter to keep it clean and avoid interference with other stations, then an antenna for broadcast. The antenna, luckily, doesn't really need to get changed for ATSC 3 because that's simply operating on RF frequency. The antenna,
which it already knows how to do.
It knows how to do. It's all based on what frequency am I, what pattern do I want, and the fact that it's ATSC 3. There are some tweaks, polarization and things like that, but you don't have to make a lot of changes there. Then it's broadcast, and at the home, it comes into devices. Now you're going to need a ATSC 3 tuner in some device. One statement right here, ATSC 3 is not backwards compatible with ATSC 1.
This was one of my questions, and I want to make sure this is very clear to everybody.
Yep.
Not backwards compatible.
this was a conscious decision right at the start, which is if you're going to go through a transition, it's a difficult thing. It involves lots of components, lots of learning. You want to make sure that what you move to is sufficiently advanced to be worth all the effort. Mm-hmm. If you kept backwards compatibility, there are limits on how far forward you can go.
And this was, and you said that ATSC 2.0 had been designed to be backwards compatible, but then it got superseded by all these other capabilities that were coming along, and people decided, okay, we better go to the more advanced system. But by doing so, you give up backward compatibility. That's one of the prices you pay.
That's true. But there are, when you do that, there's also thought about how do I do a transition?
Right.
If there are no simple ways to do transitions to let people use the equipment they already have, it's a very difficult thing to do. So this is not work in the standards body. This is work other places like National Association of Broadcasters, Consumer Technology Association, National Association. No, I said that. No, but there's a number of different outfits that are focused on this that are looking at what kinds of things can we do in transition. So devices like, there are likely to be the equivalent of a set-top box, something that takes an ATSC 3 from an antenna and puts out HDMI into existing TVs. But there are other devices.
That's one thing I was going to ask, because no TV has a tuner in it, an ATSC 3.0 tuner in it.
Right.
And it reminds me of the days when we transitioned from analog to digital, and there were all these little set-top converter boxes to take digital in and send analog out to old TVs. Now we're talking sort of about the same thing, but all digital in both directions.
There's actually going to be a whole spectrum of things. There will be ATSC 3 TVs.
Yes, of course.
Timing we'll talk about later.
Yeah.
There will be a lot of people who have old TVs and want to be able to get stuff into it. But instead of a set-top box, there's even the notion of something that looks like a Chromecast or an Amazon Fire Stick that goes into the HDMI, but has the ATSC 3 tuner and decoder in the stick.
Wouldn't
so
that be
instead
cool?
of a set-top box, it's a little thing. Well, there's even cooler ones coming. People are experimenting with and actually have produced something called a gateway device, which essentially hooks up to an antenna, even though some of them might even have steerable antennas built in. It receives ATSC 3 and either transcodes or does one of a number of things and puts it onto the network in the house, the Wi-Fi in the house. And then you'd be able to pick up ATSC 3 on your phone, your tablet, your smart TV, which
anything
really
that's hooked up to your home network.
That's right.
Yeah, wow. That does sound cool.
So there's a whole bunch of different things. And there's even one product likely to come to market, which might be a case for a smartphone that has, extra battery and other things. But it also has an antenna built into the case and a ATSC 3 tuner. So you can plop one of these on your smartphone, and all of a sudden it becomes an ATSC 3 TV.
Wow. Well, we've got a lot more to talk about, and there are a number of questions in the chat room I have noticed, so I want to get to those as well. But before we do, I'd like to take a moment to thank one of our sponsors for this episode, which is Epson. Now, Epson's revolutionary cartridge-free EcoTank line of printers for home and office introduce a new age in printing. The EcoTank ET4550 wireless all-in-one printer doesn't use ink cartridges. Instead, it features an amazing, innovative, refillable ink tank, earning it the title of CES 2016 Innovation Awards honoree. So there's no more out-of-ink frustration. It includes up to 2 years of ink, equal to about 11,000 black pages or 8,500 color pages. You can save up to 80% on ink with low-cost replacement bottles. It's powered by Precision Core printing technology. It has auto two-sided printing and a 30-page auto document feeder, and easy wireless printing from tablets and smartphones. All EcoTank printers deliver an unbeatable combination of convenience and value. With Epson's EcoTank line of printers, you'll have the freedom to print without running out of ink. In fact, the Epson EcoTank system was named the 2016 Small Biz Windows Printer of the Year. So visit epson.com/ecotank today to transform the way your home, office, or work group prints. For the best combination of ease and value, turn to the Epson EcoTank printers. That's epson.com/ecotank. And we thank Epson very much for their support of Home Theater Geeks. Epson, exceed your vision. So we got a number of questions in the chat room here, Rich. So let me pass along a couple of them to you.
Sure.
Let's see. One of them is from Muchacho. What signal will 3.0 deliver? I'm not quite sure I know the nature of that question. Seems to me it would be roughly the same basic type of signal, that is RF, radio frequency, that we get now. It just it has different information in it.
Yeah, it's going to be an RF signal. It is quite a bit different than today's system. It's using OFDM instead of 8BSB. It has the capability of splitting the channel into multiple pipes with different levels of robustness. But it is a broadcast RF signal that carries all the information modulated.
Right. Although it's also coming, there's some of it coming in via the internet.
Right, the broadband. Yep.
The broadband, right, exactly. Now, here's something interesting. Punter Joe says, we are currently using ATSC 2.0. ATSC 1.0 was a ghost suppression system for NTSC transmissions. I've never heard that before. Have you?
Well, one of the early standards, and I can't remember the number, was exactly that. The phrase ATSC 1.0 didn't get coined until maybe a year ago when ATSC 3 really started crystallizing.
Before that, it was just known as ATSC, right?
Well, what we referred to is actually the standards numbers. So A53 was the base standard for what we're now calling ATSC 1.0.
Ah, okay.
And that was probably an A40 something.
Okay. Emily the Strange is asking, wait, is this hardware technology in the TV or broadcasting from the stations? The answer really is both. It's an entire end-to-end system, reworking of the entire broadcast system, right?
That's correct.
Yeah. Barfel says, I'm surprised that 4K would take that much more bandwidth using MPEG compression. Well, I guess the new compression scheme, HEVC, is a form of MPEG, is it not?
Yeah, HEVC is the newest video coding technology out of MPEG. MPEG 2 was what we were using in ATSC 1. MPEG 4, which is also known as AVC, which is also known as H.264, is the next generation that was actually used in ATSC 2.0. And HEVC, which is more formally known as H.265, is the most recent coding technology out of MPEG. Each one saves about a half in bandwidth. So MPEG 4 was twice as efficient as MPEG 2. HEVC is around twice as efficient as MPEG 4.
Right. And as they've developed HEVC or H.264, it has become more and more efficient as they've worked on it. I remember when I first saw it, it was maybe 20 or 30% more efficient. And it has steadily become more efficient as they've gotten better at it, right?
Yeah, over time, people learn more tricks, more tools. There's a curve. Basically, there's a lot of learning at the beginning, so the efficiency jumps quite a bit, but then it flattens out. When they get to the point where there's really no more knobs to turn and the gains over time are actually very small. So MPEG 2 is mostly tapped out. There's not going to be much gain in efficiency. MPEG 4, they're probably tapering off now. And HEVC is relatively new, so there's lots to learn. Each one is more complicated. Part of the reason for all of this is computing is getting more powerful, faster. And when
Right.
you do video coding, whatever you do has to be done in one frame time, 30th of a second, either the encoding or the decoding part. So as you get more powerful processing, you can do more things in a 30th of a second. So there's a lot more tricks and tools used in HEVC than there were in MPEG-2.
Mm-hmm. I wanted to talk about immersive audio, because that was one of the things in that first diagram we looked at that is being added to ATSC 3. And I recently read that that there were several immersive audio schemes, formats, whatever you want to call them, that were proposed, that were submitted to ATSC to say, hey, use us in your system. And interestingly, what I just read recently was that Dolby AC4 was selected in the US, and Fraunhofer MPEG-H was selected, I guess, for Europe and maybe elsewhere in the world. Why is there more than one audio standard being used for this?
Well, the audio, actually, it's best to describe them not quite as standards, but as systems, because they're a bit more complex than just the coding. The group in ATSC S34.2 went through a very exhaustive testing process comparing AC4 and MPEG-H, AA, and it was really, really difficult to select between them. There was no clear, this one's much, much better than the other. They were both excellent. They both offered very similar capabilities in somewhat different ways. It was an extremely difficult decision to make. So we ended up deciding to standardize both. The way it's structured, there's a part of the audio standard that describes the system. There's a part which is AC4, and there's a part which is MPEG-H. And the idea was that each region would select one of these to use for uniformity, for ease of device manufacture, and so on. So the US has selected AC4. Korea has selected MPEG-H.
Oh, I see. Okay. Still, that does make it a little more difficult for manufacturers, it seems to me, than having a single standard throughout the world, right? Because the tuner, people who put tuners into devices will have to put one kind in for devices sold in Korea and maybe elsewhere, and another kind for devices sold in the US. Isn't that kind of counterproductive?
It's not as bad as it used to be. Back when you needed hardware for audio decoding. Today it's software.
Today it's software. Okay.
You do need a bigger processor to be able to select which one to use and so on, but it's not as big a hurdle as it used to be.
Okay. What about high dynamic range? What's the status of the work there? I mean, we know that there are at least two that are used in pre-made content, HDR10 as it's colloquially known, and Dolby Vision. And then there's also HLG, hybrid log gamma, which has been mentioned in the stuff I've been reading lately as being somewhat more appropriate for live broadcast as opposed to something that has been pre-packaged. And we saw some demos of that at the SMPTE Tech Conference this week. What's the state of thinking along those lines with regard to ATSC 3?
Well, unfortunately, this is still work in progress. It's still being discussed. I can't, not allowed to disclose what's going on, what the discussion points are.
Man.
I know. I can't quite do that. I think we're pretty close to getting that all nailed down. Key things are HDR is thought to be critically important by a lot of people and needs to be available in the standards. Expect probably some activity on that and hopefully some information very soon on where we got to.
Well, I'll be looking forward to that. Muchacho in the chat room has been asking about how the current broadcast standard in some stations are broadcasting in 720p, others in 1080i. And that leads me to my next question regarding interlaced versus progressive. Will ATSC have interlaced and progressive, or will it only be progressive?
That was an interesting argument, long discussion. There's the ideal world, and then there's the real world. And part of the problem is that broadcasters have a ton of existing content. That content is interlaced, it's progressive, it's fractional frame rate, it's integer frame rate. Conversion of that is a little bit expensive in terms of effort, and the quality goes down. Mm-hmm. So the place that the standard got to is that for HD and below, both interlaced and progressive are supported, as well as fractional and integer frame rates. For 4K UHD, it's all progressive. However, integer and fractional frame rates are still supported.
Interesting. Now, integer and fractional frame rates, like, for example, instead of 30 frames per second, you actually have 29.94, is it?
It's something divided by 1.001.
Right. Why is that? Why do we even have fractional frame rates?
There's a good reason, but I'm not sure I can explain it right now.
Okay.
It's a history thing.
It's a history thing, and I think it had something to do with moving from black and white to color, if I'm not mistaken.
Might be.
Okay. Well, in any event, and then this relates sort of to frame rate, and I'm wondering what are the frame rates that are supported, and are people really thinking about doing anything higher than 30 frames per second, which is what 60 frames per second in 720p.
Yes. The frame rate support goes up to 120 frames per second. Yep.
Okay, good.
And again, there's choice. Broadcasters can choose what they want.
Right. Of course, that'll increase the bandwidth that's required to send their material, but
surprisingly not by that much.
I mean, that is kind of amazing.
Because it's all based on differences between frames. And if you increase the rate you're capturing a frame, there's less difference between them.
Okay. So the compression has more material from one frame to the next that's the same.
Yep.
Okay. Well, that makes sense. Muchacho is asking, will stations provide both 1.0 and 3.0 at the same time for a while during the transition?
During a transition period, it's very likely, in fact, not likely, it's very sure that they will. The current thought on how to actually pull off a transition in a region is to have stations cooperate and channel share. And in the simplest model, it's going to be a little bit more complicated than this. Two stations will get together, designate one of the antennas as ATSC 1, the other one as ATSC 3. They'd share on the first one, both putting ATSC 1 on there. So the RF frequency, whatever it is, would actually carry WAAA and WBBB ATSC 1 content in that one channel, and a similar thing on ATSC 3. And then over time, when they've decided there's sufficient ATSC 3 receivers in the market, and they want disenfranchised viewers, they can go back to their original transmitters and go full channel with ATSC 3. So there will be both ATSC 1 and ATSC 3 on the air during a transition.
And it's likely that there'll be some cooperation between channels who are otherwise competitors in order to make that transition smooth.
Yep. There's a lot more cooperation these days.
Yeah, that's super cool. Okay, now we're going to get super geeky because I really wanted to show people the different layers in the ATSC system. Because it's very much like the OSI model of network layers, but not exactly. So let's take a look at graphic number 5. And Rich, if you could help untangle this for us.
Sure. We've tried to actually map this to OSI, and it's not a clean mapping. It's layered like OSI is, and OSI is the network model, but it doesn't quite map out exactly. So if you start at the very bottom, you can almost think of this as what's a receiver going to do? What does it have to do piece by piece to acquire and display an ATSC 3 signal? So the first thing it has to do is kind of look at the RF space and see if there's a signal that it recognizes. So there's something in ATSC 3 called a bootstrap. It's an extremely robust, very low data carrying signal that serves as the entry point. And it says, I'm ATSC 3. But what it also says is over time, technologies might evolve. And it has the capability of saying, well, this part of it's ATSC 3 and that part's ATSC 3.1. Take the part that you want. So we can evolve this over time. It also has a little piece in it which serves as a wake up for a sleeping receiver if there's an emergency. So if you want to send out an emergency alert, say an earthquake or a tornado or whatever, these bits will actually be received by a receiver that's in standby and wake it up and tell it, pay attention, something important is happening. Then this bootstrap, besides saying I'm ATSC 3, it gives the few parameters that are needed to start decoding the physical layer. The timing, the spacing, what frequency, what channel bandwidth, different parameters. So that's the transmission layer that you see there. That's really the physical layer, or the RF and the demodulation. And it's based on OFDM.
OFDM stands for?
Orthogonal frequency division and modulation, I think.
Okay.
It's a fairly complex system. It's very advanced. It lets you do lots of different things, including being able to split a RF channel into different pieces with different robustness. So one piece of it can be targeted at moving receivers, say in a car or a train, and another piece can carry more bits for a antenna on the roof. Very, very flexible.
Okay, cool.
So once you get that, you can demodulate and start extracting the bits out of it, so you get a stream of bits. That becomes the protocol layer, which turns the stream of bits into components. This part's audio, this part's video, as well as a bunch of metadata that describes what each of these are, how to put them together, how to use them. So this is sort of the transport layer, the plumbing, if you will, that gets objects put back together again and into decoders. Once you have that, it goes into a presentation layer, which is where all the decoders, the picture and sound is derived, captioning, other pieces, and then an application layer, which is the software, interactive components, the player itself, program guide, and that type of thing. So it's all a layered system. We actually built the committee structure to match the layering so that each committee worked on one particular thing.
That's funny, but very interesting and probably very efficient and a good way to do it. That's great.
It worked. You get the experts in one area that know what they're talking about. Yeah.
Well, we got some more questions in the chat room, but before we get to those, let me thank our other sponsor for this episode, which is Grasshopper. Grasshopper is a virtual phone system designed for entrepreneurs. Grasshopper works just like a traditional phone system, but it requires no hardware purchase or software installation. With their iOS and Android app, callers can reach you wherever you are on your mobile phone. Grasshopper allows you to keep your existing phone number so you can maintain your brand. When you make a call, your client will see your Grasshopper caller ID instead of your personal phone number. That's pretty cool. Simply select a toll-free or local number, record a custom greeting, and add multiple extensions for your business. Toll-free numbers are great for marketing and make your business sound more professional. You can set up department and employee extensions with custom call forwarding to any phone in the world. And you can get voicemails emailed to you as audio attachments. You can also send and receive SMS text messages from your business number. Join over 250,000 Grasshopper customers today. Plans start at just $12 a month, and you have a 30-day money-back guarantee. Turn your smartphone into a business line with Grasshopper. To save $50 on your order, go to trygrasshopper.com/twit. That's trygrasshopper.com/twit. And we thank Grasshopper very much for their support of Home Theater Geeks. Okay, a couple of more questions from the chat room here. Terry K asks, what legislative and regulatory hurdles must be met for 3.0 implementation? And is there a target date to launch?
Yeah, in order for ATSC 3 to go on the air, the FCC needs to approve broadcasting it. You can't just stick up an antenna and broadcast anything you feel like, especially in certain bands. You tend to get visited by people you don't want to see. So actually a petition was put into the FCC to allow ATSC 3 broadcast, and it's being considered right now. So the biggest regulatory event is really for the FCC to approve broadcasting ATSC 3.
And is there sort of any estimation of when that might occur?
Well, the desire was sooner rather than later. Information I'm hearing, I think they are acting on it expeditiously.
Good. Let's see. User 0384 is going back to audio. What quality will it be? Will it be 24-bit, and at what sample rate? I assume that that's sort of up to the broadcaster as well.
That's part of it, but the 24-bit and the sample rate is almost before you get into the coding. There's quite a bit of flexibility that the broadcaster can choose. The things that I didn't quite get into on the audio is it's a totally new system of audio, whether it's AC4 or MPEG-H. Instead of being purely channel-based like today's systems are, it's channel-based and object-based. So you can set up audio objects, which have, besides the audio information, also have other characteristics like where they're located, and that location can be changed. And they can be dealt with individually. The coding technology itself is more efficient. It's approximately twice as efficient as the second generation audio, which is twice as efficient as the first. So we gain a lot there. The quality can be probably higher than today's audio if you want. One of the interesting things is because it's not completely channel-based, there's a renderer involved. And the renderer can do different things with the audio stream based on the equipment that it finds. So one of the problems you have with, for example, surround sound is that nobody ever puts the speakers in the right place. Either because there's a doorway or a window or their spouse doesn't want the speaker there. Right. So everything's misplaced. This renderer can actually take that into account and render things according to the actual speaker positions or the number of speakers. It also has the capability of being able to deal with different elements individually. So one example, this is probably going to be how the advanced audio is going to roll out. If it's sports, you can have different announcers as objects, the home team announcer, the away announcer, and people watching can choose which one they want to hear and turn the other one down, or turn them both down if they don't want to hear it. Or for people that have hearing issues, a common problem is being able to hear the dialogue amongst the effects. So the ability to simply reach in and boost the dialogue channel. Very simple thing, but probably very effective.
Very effective. Yes, exactly. Let's see. Emily the Strange is asking, does this work with PAL in Europe as well? Or is there even a PAL anymore?
See, all that's blurred. The decoders can decode and play out to whatever they're playing into, but I think the PAL and NTSC distinctions are pretty much gone these days. Kind of what I thought.
Yeah, exactly. I want to take a look at the timeline here, which is graphic number 8. And take a look at sort of how things have been progressing. We touched on this at the beginning, but here now, towards much later in the show, I want to show people exactly kind of what the timeline is. It's been going, you've been planning it since 2010, 6 years ago, right?
Yeah. Yep. So when you start something like this, the first step is to go through a planning phase and figure out what it is you might want to do. Work out the scope of it, work out how much activity, how much effort, and then make the decision, is it really worth what you're going to need to do? Is it worth what the results are going to be? Mm-hmm. So that was a couple-year activity that was actually taken up in a special group that reported to the ATSC board. When the decision was made to go ahead, the next step is to work out requirements. What does the system have to be able to do? So, simple things like better video, better audio, being able to deal with accessibility issues, supporting emergency alerting, so on and so forth. A whole slew of requirements were put together where people could look at these and understand what it was they were trying to build. That was a couple of year activity, and this is usually time well spent, because if you set out the requirements correctly for a project, you can actually build what people want if they've all agreed that's what the requirements were. Mm-hmm. Then the standards development, 2013 to early into next year. This is a timeline that was pretty much set up about 4 years ago, and we're still pretty much on the timeline, which is amazing.
That is amazing.
And then, a period of time when the standards are all finished, then you get products starting to emerge. First, you get prototypes and trials, and then productization. We're heading into that phase. It looks like a long time, but if you look at the amount of work that was done, the amount of output, this is incredibly short. Interestingly, participation in this is worldwide. We have people from the US, Canada, Europe, different places, Korea, Japan, China, all contributing. Probably 300 or 400 engineers directly interfacing in, and many people behind them in their companies. So this has been a massive effort.
Mm-hmm. So what parts of ATSC 3 would you say are final now, done, have standards, ready to go, and which parts are not?
So there are actually, if anybody's interested, if you go to www.atsc.org, you can freely access any of the standards, the final ones, as well as what we call candidate standards. A number of them are completed. The physical layer, the bootstrap and the physical layer are completed, as is a couple of plumbing type things, an abstraction layer protocol, watermark emission, and so on. There's a whole slew that are expected to go to finalization towards the end of this year, early next year. We do have a phase that a lot of these standards are in at the moment, called candidate standard. And that's where most of the work is done. People have something they think is correct. It's something that can be built, but it's complicated, and we'd like to let people kick the tires before finalizing it. So we go through a ballot for this candidate standard phase where it's publicly available. People can build it. And usually when they build it, they find things that maybe weren't quite written as well as they could be, or maybe get interpreted differently. We can fix them during this phase, and then when we're confident that they're done, we then put them in for final ballot. So the majority of the ATSC 3 system is in this candidate standard status.
Mm-hmm. And
now,
of course,
it is possible to actually read those.
Sorry, go right ahead.
I was saying those are publicly available. So if anybody's curious and they go to that website, they can see all this information.
Mm-hmm. And you mentioned to me before we did the show that how important standards really are to this process. Can you speak a bit to that?
Yeah, well, actually, standards are quite important to all kinds of things. And there's something that most people don't even think about. The fact that you can go to a store, buy a lamp, plug it into the wall, turn it on, and it works without smoke and fire and everything else is due to a whole bunch of standards. There's one country over in Europe that didn't have standardized plugs and outlets, and you had to buy whatever plug you had to match the outlets in your house and wire it yourself. And there were a bunch of fires, and they ended up standardizing that. So standards are incredibly important. When it comes to television, just the observation that you can buy any TV you want and tune it to any broadcast station that you want, and it works, is all because of standards. Broadcasters are emitting according to a standard. The CE receiver designers are building to the standard. So we really need the standards. The place that you have to be careful is if you specify normatively everything, every little detail, you end up with a system where there's no innovation, and you end up essentially in a race to the bottom as people try to make the same thing as cheap as possible. So you have to be careful that you standardize enough to make everything work together, but you leave room for innovation, invention, and differentiation between either products or broadcasters. So a lot of this is done by talking about what we call bits on the wire. What's in the emission? Describe the emission signal and the coding and so on, but not tell people how to either encode it or decode it and leave room for innovation there. And I think we've been fairly successful in walking that fine line.
Sirstas in the chat room is asking, is the emergency broadcast system switching over to ATSC 3?
There's a lot of support for emergency alerting in ATSC 3. So emergency broadcasting system is actually a fairly old phrase. It goes back to when people were scared of nuclear attacks and so on. There is a emergency system today, IPAWS and a number of other things, which distributes emergency information to broadcast stations, to first responders, to a lot of different places. Some of it's based on radio signals, some of it's based on TV signals, some of it's based on internet. What we're looking at is the last mile. Once there is an emergency of some sort, how do you get the right kind of information to the public? So I mentioned the wake-up bits, where if there's an emergency, you can actually wake up a sleeping receiver. Broadcasters still do what they've done for a long time, and they're required to do, which is if there's an emergency, they put a text crawl across the video, they put audio into the audio track, and do that. What the new capabilities include is going beyond that and adding additional rich media to the broadcast to put up, say, evacuation maps in the case of a hurricane, or videos of weather maps or instructions. Basically, anything you can think of that can be displayed on a TV can be actually put into the broadcast and associated with an emergency. So it's a much richer system now.
A couple of people are talking about the conversion. Mike Heiss in the chat room is saying, word is that we will not see a $40 coupon for the converter box like we did for the transition from analog to digital. So, you know, as we talked about earlier, the set-top box, you'll probably start with a set-top box before TVs actually have a tuner in them, right?
Yeah, I mean, the converter program, that was all based on the original transition. Part of the deal there was that the broadcasters were given a bit of extra spectrum to experiment and to build out ATSC 1 and put analog and digital on the air at the same time. At the end of the conversion, they'd give that back plus some. So there would be more spectrum given back that could be sold, money made by the government, and they funded a converter box program. Now there's no extra spectrum. Broadcasters are not going to get extra. There is an auction and a repack going on to reduce the broadcast space, but that's independent of this. You're not going to see another converter box program funded by the government again.
Well, that brings up a question I had for you, which was, what spectrum is being used? Is it different from the current broadcast spectrum, or is it just being interleaved in there, or How does that
Well,
work?
this is the part of the transition, the channel sharing notion that I mentioned before.
Mm-hmm.
There is no more spectrum. The auction and repack that's going on will ultimately reduce the amount of spectrum the broadcasters have. So over time, the repack is going to shrink the broadcast space, and the ATSC 3 transmissions have to fit within there. So during the transition time, by channel sharing, they're going to kind of, you can think of it as interspersing. Some of the channels will be ATSC 1, some ATSC 3. After the full transition, it's all going to be ATSC 3, but in the same space we have now, or the reduced space after the repack.
Does each channel still get 6 megahertz bandwidth? That's the broadcast bandwidth per channel, right?
Right. In the U.S., it's 6 megahertz. That's what the FCC has regulated.
Mm-hmm.
The system itself currently can do 6, 7, or 8 megahertz. It can be extended further. So in the future, or different regions, the U.S. is 6. Europe, for example, is 8. So the standard can do more, but the U.S. by regulation is only 6 megahertz channels.
Mm-hmm. UJ in the chat room is asking, is there any effort to relocate the tuner from within the display to a set-top box? That's not of any concern really to ATSC, is it? That's up to manufacturers to say, I'm going to put a tuner in my TV or I'm not.
That's up to manufacturers, except there is an FCC regulation that I don't know the exact wording, but if you call it a television and it used to be above a certain size, now it's any of them, it has to have a tuner. There is a manufacturer that's making something and put it on the market that they don't call a television, which doesn't have a tuner.
Ah, right.
I'm not sure
they call
exactly
that a monitor.
the word.
I think monitor is the one, certainly the word I use to differentiate.
Probably correct.
A display with a tuner is a TV. A display without a tuner is a monitor. Rusty Bones is asking, what, if any, concerns are there for this new system to be hacked?
Actually, we have it didn't show on the diagram, but we have a specialist group focused on security. It goes beyond, typically when you think of television and entertainment, you think of things like conditional access or DRM. Some services might be services that are premium and the provider might want you to pay for. Or it may be that by making a certain arrangement, you get access to premium services that you wouldn't get if you didn't agree to whatever. That's one piece. But the other bit is we now have interactivity, we have broadband, TVs.
Yeah, that's what I'm thinking.
Like
you have
computer.
You have a broadband component to this, which could seem to me to be hacked.
Yep, and so there's that group. It's actually easier to work out the security details for that part than it is the broadcast, because the internet is the model, and the practices and rules for security there have been picked up and brought over. So it's not inventing out of whole cloth. It's using best practices established for the internet and twisting them to make them usable in television.
Yeah.
But yeah, it's an area we focused on very intensely.
Good. Mike Heiss in the chat room is reminding me that I wanted to mention that there has actually now been and is continuing to be some test broadcasts of ATSC 3.0 from a station in Cleveland, WJW, which is broadcasting the World Series in ATSC 3.0, which of course no consumer can get because there are no consumer receivers yet. I guess this is really just to sort of test out the system, huh?
Yeah, that's actually, there's a few stations actually doing test broadcasts. So I'll talk about this one and describe the others next.
Okay.
But that station in Cleveland was used during the transition from analog to digital. I don't remember the exact details.
That was the same station, really?
Yeah, and it went dark. It was sitting there in mothballs for a number of years. And about a year plus ago, National Association of Broadcasters worked out arrangements, and they're operating it, got permission to go on the air as experimental. Apparently, the stories of getting that thing fired up again were kind of amusing, interesting.
Yes.
And they first started doing just ATSC 3 transmissions to look at coverage and see how things worked in moving in cars driving down the highway in different places. But they took advantage recently yesterday. Since the World Series is going on, they actually got it together to take a feed from the World Series and broadcast it in ATSC 3. As you said, there were very few receivers. Turns out there were two TVs that are able to receive ATSC 3, one in the station. The other one was sitting in a truck or a van outside the stadium where they were showing the broadcast in ATSC 3. Mostly it was, as obviously promotional, but it was successful.
Yeah.
The guys, as I mentioned in an email to you, two of the guys instrumental in pulling it off are on either side of my office. They went out.
So they're in Cleveland right now, probably, right?
No, they just got back.
Oh, okay.
So I checked with them what they actually did. Besides that, and a lot of this use, they've been doing a lot of work on looking at coverage, especially for mobile situations.
You're talking about from an antenna, how far will it go, or what area will it cover?
How far will it go? How's it received in urban areas? The urban canyons with lots of buildings. How does it received inside? How is it received in a car doing 70 miles an hour on the highway? And the answer is actually pretty good. There's also two other experiments going on that I know of. There may be more. Down in Raleigh, WRAL has got an ATSC 3 broadcast on the air. I think they're doing in parallel with what they're putting on ATSC 1. Again, experimental. A lot of it is looking at coverage. And in Baltimore, and I forget the call letters, but Sinclair is experimenting with single frequency networks with ATSC 3.
I don't know what single frequency networks means.
One of the things with broadcasting is reception depends on how much signal you can get into the antenna, and it may depend on directionality. There are places, because of terrain, mountains, hills, whatever, where there are areas that are blocked. You simply can't get a signal there from the antenna, the primary antenna you're using. So if you put up auxiliary antennas to cover that area, one of the problems that you have is if you try to put them on the same frequency, they start interfering with each other. So there's this idea of something called a single frequency network, where each of these antennas emits the signal, the symbols making up the signal, at exactly the same time. Exactly the same information, exactly the same time. And a receiver will see these two different signals and think that one of them might be a reflection of something else and ignore it. So you can actually get this to work without interference. Now, it's a lot more complicated than that, but that's kind of a simplistic view of how it does.
Yeah.
And it works quite well. ATSC 3 has a lot of functionality designed to allow that to happen.
Okay. Speaking of antennas, what about reception antennas? Do I need anything different to receive ATSC 3 as compared to 1? I would think not. No,
it's the antenna is really a matter of physics, the wavelength, the same relationships. It's an RF signal. The length of the antenna is really related to the frequency of the transmission. So for low VHF, you need large antennas. For high UHF, you need small antennas. And it's exactly the same between 1.0 and 3.0.
Well, thank you so much for being here. It's been a fascinating exploration of the new broadcast standard, which is being experimented with now, but we should actually see product sometime next year, maybe even broadcast next year, in the next year or two, wouldn't you say?
I'd say it's going to be mass products probably in about 2 years. Next year's going to be a lot of experimentation and trial. You get a bit of a chicken and egg. Broadcasters don't want to broadcast until there's receivers, and receiver folks don't want to make them until there's broadcasts.
Yeah, always the case, isn't it?
Yep, typically the broadcasters go first.
So by CES 2018, we should see some real product that people can buy, and hopefully some broadcasting that they can get and enter into this new world.
I think that's correct.
Okay. Well, thank you so much. That's Rich Chernock, CSO, Chief Science Officer of Triveni Digital, which is a company thick into the broadcasting end of things. But he really knows his stuff when it comes to ATSC, and I thank you so much for being here to explain it to us. And
thank you for inviting me on.
You bet. So go to find out about Triveni, you can go to trivenidigital.com. And as Rich mentioned, go to ATSC.org to find all sorts of information about ATSC and where the standards are and what's going on with that. So that's a lot of really geeky information there that I highly recommend. You can always find me on avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and at AVS Forum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/HTG and our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be Mike Heiss, a longtime AV industry veteran journalist and analyst who I think is often in the chat room. I think he is today. We're going to be talking about the SMPTE Tech Conference that both of us just attended. Now, you should know that we're going to be pre-recording this show tomorrow, Friday, October 28th, from 5:30 to 6:30 p.m. Pacific time, because I'm not available to do it at the normal time next week. It'll be aired on November 3rd. But if you want to get in on the live action, tune in tomorrow from 5:30 to 6:30 at live.twit.tv. And you'll be able to ask questions and interact with us as we talk about the SMPTE Tech Conference, which was really quite fascinating. And there's an awful lot to talk about there. So do hope you will join us for that. Until then, geek out.